this material. Where's the difference? Because why? This is pure copper. If you add 1.12% nickel into copper, what is going to happen? You do see an increase in the resistivity value, right? Now, let's look at, this is number 1. Okay, let's look at number 2. Now, let's look at this line. Why this line shows a higher resistivity as compared to this line? Why do we see a higher resistivity value for this line as compared to this line? Because we have more nickel here, right? Now, the question is, what about number 3? If you have more and more nickel added to copper, then your resistivity of copper keep increasing as you increase the value of nickel, okay, when you compare to the value for pure copper, okay? So, the first conclusion I'm going to draw from looking at this figure is that adding impurity atoms to copper increases resistivity. Okay, so this figure is a change of property as a function of temperature. Okay, pure copper, then 1% nickel, 2% nickel, 3% nickel added to copper. The resistivity value of copper-nickel alloy will be totally different than the metal without nickel. Okay, so the first conclusion is adding impurity atoms to copper increases resistivity. Now, what are these impurity atoms? These are what? Nickel, right? So nickel, because nickel is added to copper only at a very small amount. So if you add only 1%, 2%, 3%, very small amount of nickel to copper, the resistivity can change, but the amount of nickel is really small. That's why we call nickel as impurity atoms to copper. Okay, now what do we mean by impurity? 这个词什么意思啊？大家见过？什么叫 impurity？ 杂质。Okay. Now let's compare these two lines. If you compare this line with that line, the resistivity value is also different. Why? What caused the difference in the resistivity value between those two lines? You can see this line number 1 is copper with 1.12% nickel, right? Now what about this one? The second line is the same material, copper with 1.12% nickel. But the difference is what? Here we have another word, deformed. What does deform mean? Deform means you change shape of a material. You change the shape of a material. For example, you have a material that is rectangular. Then you make it longer by extrusion or by giving a lot of pressure. Then you are deforming that material. Okay. Therefore, if you deform the same material, what you will get is actually you change the resistivity of the material. Why? This is something you need to know from learning this course. Because when you deform a material, the crystal structure, the grain structure, or even the atomic structure is going to change. Therefore, the resistivity of the same material will be different. Okay, so the second conclusion that we can have is deforming copper increases resistivity. This is how you want to do scientific research. You carry out a lot of experiments. Then you generate this kind of figure, or you generate this kind of relationship between your resistivity and temperature. Then you can draw several conclusions. So this is science. Okay? So I'm using this figure to explain in detail in order to show you guys how to explain an experimental data in material science lab. Okay, so I'm going to go through these very quick. I think thermal properties. When we talk about thermal properties, most of the property we mean will be thermal conductivity. Because a lot of material will be a good conductor for heat, but some material just cannot conduct heat. Okay, so let's look at this, space shuttle tiles. What is space shuttle? Everyone knows what is space shuttle, come on. Okay, what is tile? Tile 只是咱们比如装修那种瓷砖一块一块的，或者说 space shuttle 表面贴那些东西都叫做 tile. Okay, so they use silica fiber insulation. They offer very low heat conduction because the material is very advanced. So it just cannot conduct heat. Therefore, it can keep the space shuttle at the same temperature. Now, if you look at the thermal conductivity of copper on the right, okay? Now look at this figure. This is the thermal conductivity of copper. Now this is a composition. Now what is composition? Composition is what? How much copper are there? How much nickel are there? How much other elements are added, right? So composition. Now this horizontal axis is the composition of zinc. Now what is zinc? Right. This is zinc. Now look at this figure. If you add a lot of zinc in it, what's going to happen? You will effectively decrease the thermal conductivity. So if you add zinc into copper, it just cannot be as good as before. It just cannot conduct heat as well as before. So that's what we say, the thermal conductivity of copper decreases when you add zinc. So by adding different alloying elements into your material, it can effectively influence your original properties, such as electrical and thermal. Now, let's look at magnetic. Everybody knows our recording medium. Okay, recording medium, such as your tape, okay, is magnetized by the recording head. So there's one important magnetic property is called the magnetic permeability. Okay, now let's look at this figure. This figure shows the magnetization as a function of magnetic field. So if you compare iron and iron with 3% silicon, okay, so if you have a higher and higher magnetic field, then your magnetization is going to increase. So what's going to happen if you add 3% silicon into iron? It increases your magnetization very well to a large extent. Therefore, we say adding 3% silicon makes iron a better recording medium because magnetization is much better than before. So it improves your property by providing a better recording medium of your recording head. So by this way, people will change material to make it perform better. So optical. Optical is very important. Of course, let's look at optical transmittance. Now what is transmittance? Transmittance, it means this material can, if light can be transmitted through this material. Okay, so this is called the transmittance of a material. Okay, so let's look at aluminum oxide as an example. Now, what is aluminum oxide? What is aluminum oxide? Tell me, what is aluminum oxide? What is that? Al2O3, right? This is aluminum oxide. Okay, so here we have 3 samples for aluminum oxide. It can be made either transparent, either translucent, or opaque.